Dear students, welcome to mathematics online classes. In the last class, we have studied about a special series, sum of special series, and we have solved some problems also. Now, in the exercise 9.4, remaining problems we are going to solve now. This is exercise 9.4, second problem we are taking. Before solving the problem, let us revise the formulae we have studied. What are those? Summation of k, where k varies from 1 to n. What is summation of k? It is sum of first n natural numbers, 1 plus 2 plus 3 up to n. We have studied this as n into n plus 1 by 2. This is the formula we have studied. Next, what about summation of k square, where k varies from 1 to n? This is n into n plus 1 into 2n plus 1 whole divided by 6. Next, summation of k cube, where k varies from 1 to n, means it is sum of cubes of first n natural numbers. We have studied this one as n into n plus 1 by 2 whole square, or this can be written as n square into n plus 1 whole square divided by 4. And Sn formula, Sn is summation of ak, where k varies from 1 to n. What is ak? Ak is nth term, means kth term here, n we have replaced by k, ak is equal to, that will be the nth term. What does it mean actually? Sn is equal to k varies from 1 to n, means when k is equal to 1, this is a1, next 2, 3, so on up to how many terms? N terms are there, an it is. Like that we will be taking the sum of first n terms of the given series, whose nth term we will be calculating. You see here, there is a special series given. First term is 1 into 2 into 3, second term is 2 into 3 into 4, and for third term is 3 into 4 into 5, like that it is given to us. Now, first of all, our job is to find out the nth term. How will you find out the nth term? An is equal to, here you see product of 3 series are there, 1, 2, 3, this is the first sequence, and now this is 2, 3, 4, this is the second sequence, 3, 4, 5 is the third sequence, like that it is proceeding. An is nothing but nth term of 1, 2, 3, this first term I am taking, so on, which is multiplied with next nth term of 2, 3, 4, middle terms I am taking 2, 3, 4, so on, into nth term of what are those? 3, 4, 5, that last one, 3, 4, 5, so on. Nth term of this series I am going to find. An is equal to, see 1, 2, 3, you can observe it is in arithmetic progression, okay, with a is equal to 1, and number of terms are how many? Number of terms are n terms are there here. And what about the common difference? Common difference is a2 minus a1, that is nothing but 1. And here in the second term, first term a is equal to 2, and the common difference d is equal to 3 minus 2 is again 1 only. What about this? First term a is equal to 3 and the common difference is 1. Okay. Here what I am finding? I am finding the nth term. We will use the formula using an is equal to a plus n minus 1 into d. Now an of this special series, I am using this formula in all 3 terms. A is 1 here, 1 plus n minus 1 into d is 1, which is multiplied with the second one, 2 plus n minus 1 into 1 into 3 plus n minus 1 into 1, like that it is going. Now here we have 1 plus n minus 1, which is multiplied with 2 plus n minus 1 multiplied with 3 plus n minus 1, okay, plus 1 minus 1 get cancel, n into this one is n plus 1 into this one is n plus 2. This is an what we are calculating. Now an is equal to n as it is. Let me multiply this n into n square, n into 2 2n, 1 into n 1 into 2 2. This is n into n square plus 3n plus 2. an is equal to, you multiply this n also, this become n cube plus 3n square plus 2n. This is about nth term of the special series. Okay, you replace n by k. ak is equal to k cube plus 3 into k square plus 2 into k. Nth term we found, and we found ak also. Now finding Sn. Sn is equal to, we have the formula in case of special series. Sn is equal to summation of ak, where k varies from 1 to n. This one we know already. Now you put ak, summation of ak is k cube plus 3k square plus 2k, where k varies from 1 to n. You can take the summation for each term separately. First one will be summation of k cube, where k varies from 1 to n, plus 3 is a constant multiple, you can write out of the summation. 3 into summation of k square, where k varies from 1 to n, plus here also 2 is a constant multiple, you write out of the summation. 2 into summation of k, where k varies from 1 to n. Now we can use the formula. What is summation of k cube? Summation of k cube means 1 cube plus 2 cube plus 3 cube so on up to n cube, means sum of cubes of first n natural numbers. We have the standard formula n square into n plus 1 whole square divided by 4 plus of 3 into summation of k square means sum of squares of first n natural numbers. Sum of squares of first n natural numbers formula n into n plus 1 into 2n plus 1 divided by 6 plus of 2 into summation of k is nothing but n into n plus 1 by 2. Okay, here you see 3 ones are 3 twos are, and here 2 to get cancels out. Now you take the common. What is common from all three terms? Common is n into n plus 1 is common. N into n plus 1 is common. Okay, remaining you write n into n plus 1 divided by 4 plus of n into n plus 1 is already taken common. This become 2n plus 1 divided by 2. n into n plus 1 is outside, only 1 remains over there. 2 has already got cancelled. Now this is equal to n into n plus 1 into, what is the LCM of all these three terms? LCM is 4. Now n into n plus 1 plus 2 2s are, means 2 into 2n plus 1 plus of 4. n into n plus 1 into n you multiply, n into n square, n into 1 n plus of 2 you multiply, 2 into 2 4n plus 2 plus 4 whole divided by 4. This is equal to n into n plus 1 into n square plus n plus 4n 5n 2 plus 4 6 whole divided by 4. Okay, this one we can simplify. This is equal to n into n plus 1 into, you see n square plus 5n plus 6 is a quadratic equation. This quadratic equation can be simplified by splitting the middle term. N square product should be 6, sum should be 5. Like that I can choose 3 and 2. N square plus 2n plus 3n plus 6 I will write, whole divided by 4, which is equal to n into n plus 1 into n you take common, n plus 2 plus 3 you take common, n plus 2 whole divided by 4. This is equal to n into n plus 1 is already outside, n plus 2 is common from this into n plus 3 whole divided by 4. This is the Sn is equal to sum of first n terms of this special series, where special series given is this one. Now taking the next problem, that is problem number 3 in the exercise 9.4. It says there is a special series 3 into 1 square plus 5 into 2 square plus 7 into 3 square, so on like that. Now an is equal to nth term, an is equal to nth term of 3 comma 5 comma 7 so on into nth term of 1 square comma 2 square comma 3 square, so on. Now what is nth term of this 3 comma 5 comma 7? You see these three terms are in arithmetic progression. ಅವು arithmetic progression ಅಲ್ಲಿ ಇದಾವು. ಹಾಗಾದರೆ what is the first term here? A is equal to 3, common difference D is equal to 5 minus 3 is nothing but 2. I will use the formula an is equal to a plus n minus 1 into d to find the nth term of that. Coming to second one, what will be the nth term here? See, first term is 1 square, second term is 2 square, third term is 3 square. What will be the 10th term? It will be 10 square. In the same way, what will be the nth term? That is n square. That's all. Okay. An is equal to 3 plus n minus 1 into 2, using this formula for this first sequence, into n square. I will write directly. An is equal to 3 plus this 2 get multiplies with these 2, 2n minus 2 into n square. This is 2n plus 1 into n square. 2n into n square is 2n cube. N square into 1 n square. This is what an is equal to. Now what is ak is equal to 2 into k cube plus k square. N is equal to k. I am replacing. This is about ak. Now coming to the Sn. Sn is equal to summation of ak, where k varies from 1 to n. This one we know. Summation of ak is 2k cube plus k square, where k varies from 1 to n. This is nothing but 2 times summation of k cube, where k varies from 1 to n, plus summation of k square, where k varies from 1 to n. 2 into summation of k cube is a sum of cubes of first n natural numbers. We have the formula n square into n plus 1 whole square divided by 4 plus of summation of k square is n into n plus 1 into 2n plus 1 divided by 6. 2 1s are 2 2s are I can write. What is common from these two terms? Common is n into n plus 1 from the numerator, and from the denominator 2 I can take common. Okay. This is n into n plus 1 by 2 common from the both the terms. Remaining you write n into n plus 1 here, and now here n into n plus 1 is outside, 2n plus 1 from in the numerator and by 3 in the denominator, which is equal to n into n plus 1 by 2 into, I can cross multiply here, 3n into n plus 1 plus 2n plus 1 whole divided by 3. This is equal to n into n plus 1 by 2 into 3n, we can multiply with n plus 1. This is 3n square plus 3n plus 2n plus 1 whole divided by 3. n into n plus 1 into 3n square plus 5n plus 1 whole divided by 2 into 3, 6. This is the sum of first n terms of the special series. With this, problem number 3 completed. Now we will go to the problem number 4. Problem number 4, it is again a special series. 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4, so on, like that it is given. To solve this problem, we will use a method known as a method of partial fractions. Partial fractions in the sense that for that word you will be new, means in simple words I will explain. Partial fraction in the sense writing a complex terms to sum or difference of 2 or 3 terms. ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಟರ್ಮ್, ಒಂದು ದೊಡ್ಡ ಟರ್ಮನ್ನು ಸಿಂಪಲ್ ಟರ್ಮ್ ಆಗಿ ಬರಿತೀವಲ್ರಿ, ಅದೇ ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ಸ್. ಓಕೆ, ಇದನ್ನು ಹೆಂಗೆ ಬರೆಯೋದು, ಇದನ್ನು ಹೆಂಗೆ ನಾವು ಸಿಂಪಲ್ ಟರ್ಮ್ ಆಗಿ ಬರಿತೀವಿ ಅಂದರೆ, ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಲೆಟ್ ಮಿ ಫೈಂಡ್ ಔಟ್ ಎ ಎನ್ ಹಿಯರ್. ಎ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 1 divided by first term numerator 1, second term numerator 1, third term numerator 1, so on. Nth term will be again, that is nth 1 only, numerator will be 1. What happens to the denominator? You see here 1, 2, 3 is there, that means nth term of 1, 2, 3, so on, which is multiplied with, it is all in denominator only, nth term of what is that, second terms you observe, 2, 3, 4, so on, which is equal to 1 whole divided by, these are again in what, these are again in arithmetic progression with a equal to 1, common difference d is equal to 1, here a is equal to 2, common difference d is equal to 1. We will use an formula here. An is equal to a plus n minus 1 into d. Now nth term of this special series is 1 divided by 1 plus n minus 1 into 1 into 2 plus n minus 1 into 1, which is equal to 1 divided by 1 plus n minus 1 into 2 plus n minus 1. This is 1 by n into n plus 1. What is this? This is an is equal to, okay, ak and all not required here, a special method I am following here. Now what is Sn is equal to? Sn is nothing but sum of all these terms. ಈ ಎಲ್ಲ ಪದಗಳ ಮೊತ್ತನೇ ನಮಗೆ Sn. ಸೊ Sn equal to I can take here 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4, so on up to what? They asked you to find sum to n terms. ಮೊದಲ n ಪದಗಳ ಮೊತ್ತ ಕಂಡುಹಿಡಿಯಿರಿ ಅಂತ ಹೇಳಿರ್ತಕ್ಕಂಥದ್ದಲ್ಲಿ. ಸೊ n ಪದ ಏನು, ಲಾಸ್ಟ್ ಪದ ಏನು, 1 by n into n plus 1 is the last term. Okay, by the method of partial fractions I will write this 1 by 1 into 2 as 1 by 1 minus 1 by 2. This is the partial fraction method. This is one complex part. ಒಂದು ದೊಡ್ಡ ಟರ್ಮ್ ಏನೋ ಐತಿ, ಪ್ರಾಡಕ್ಟ್ ಆಫ್ 2 to 3 terms are there, ಅದನ್ನು ನಾವು ಸಿಂಪಲ್ ಆಗಿ ಬರೆದಿದ್ದೆವು. ಇದು ಕರೆಕ್ಟ್ ಹೌದೋ ಇಲ್ರಿ, ಕರೆಕ್ಟ್. ಯು ಕ್ಯಾನ್ ಕ್ರಾಸ್ ಚೆಕ್ ದಿಸ್. ಹೆಂಗೆ ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡೋದು? ವಾಪಸ್ ನೀವು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿರಿ, ಏನಾಯಿತು, 2 minus 1 divided by 1 into 2. 2 minus 1 ಅಂದರೆ 1 ಆಯಿತು. Yes, whatever you wrote is correct. Now coming to the second term, 1 by 2 into 3 is there. 1 by 2 into 3 I will write 1 by 2 minus 1 by 3. Check whether it is correct or not. ಇದು ಕರೆಕ್ಟ್ ಆಯಿತೋ ಇಲ್ಲೋ ಅಂತ ನೀವು ಚೆಕ್ ಮಾಡಿರಿ. 1 by 2 minus 1 by 3. If you cross multiply, 3 minus 2 by 2 into 3. 3 minus 2 ಅಂದರೆ ಎಷ್ಟಾಯಿತು? 1 ಆಯಿತು. Means we are writing it correctly. 1 by 3 into 4 can be written as 1 by 3 minus 1 by 4. So on it goes like this. Last term also in the same way I will write 1 by n minus 1 by n plus 1. Correct? If we cross multiply, n plus 1 minus n by n into n plus 1, n get cancels, 1 will be there in the numerator. Fine. Now you see minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus 1 by 4, so on like that. How many terms will get cancels out? Up to this 1 by n get cancels out. This minus 1 by 4 also get cancels all this. And what are the terms remaining here? ಇಲ್ಲಿ ಹಿಂಗಾದರೆ ಉಳಿದಿರ್ತಕ್ಕಂಥ ಟರ್ಮ್ಗಳು ಯಾವ್ಯಾವು? ಎಸ್ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 1/1 ಈಸ್ ರಿಮೈನಿಂಗ್ ಆ್ಯಂಡ್ ಫ್ರಮ್ ದಿಸ್ ಲಾಸ್ಟ್ ಒನ್ -1/n+1 ಈಸ್ ರಿಮೈನಿಂಗ್. ಇವೆರಡೇ ಉಳಿದಿದ್ದಾವಲ್ಲಿ. ಓಕೆ, ವಿ ವಿಲ್ ಸಿಂಪ್ಲಿಫೈ ದಿಸ್. ಇಫ್ ವಿ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ this become n+1 -1/1 into n+1. +1 -1 is 0. Numerator is n divided by n+1. What is this? This is Sn. Finished. Has a simple problem it is. Method of partial fractions. We'll take the next problem. That is problem number 5. Problem number 5 is also very simple problem. We will take that problem. It says find the sum to n terms of the series. Find the sum to n terms of the series. Series given is 5 square plus 6 square plus 7 square plus so on up to 20 square. Up to 20 square they have given it. See, this is starting from 5 square plus 6 square plus 7 square, so on up to 20 square. We know the formula for which begins from 1 square, sum of squares of first n natural numbers. 1 square plus 2 square plus 3 square up to n square. ಅದೇ ಥರ 1 square plus 2 square plus 3 square up to 50 square ಅಂತ ಹೇಳಿ ಇತ್ತು ಅಂದರೆ n is equal to 50 ಅಂತ ಹೇಳಿ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿರೋ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದರೆ ನಮಗೆ ಆನ್ಸರ್ ಬರ್ತೈತಿ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ರೀ, 1 ಸ್ಕ್ವೇರ್ನಿಂದ ಅದು ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇಲ್ಲ. ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇದೆ? 5 ಸ್ಕ್ವೇರ್ನಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಇಲ್ಲೇನು ಮಾಡೋಣ್ರಿ ಅಂದರೆ ಎಸ್ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 5 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 6 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 7 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಸೋ ಆನ್ ಆಫ್ ಟು 20 ಸ್ಕ್ವೇರ್. ದಿಸ್ ಈಸ್ ಎಸ್ ಎನ್. ಎಸ್ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು, ಐ ವಿಲ್ ರೀರೈಟ್ ದಿಸ್ ಸಿರೀಸ್. ಈ ಸಿರೀಸನ್ನು ನಾನು ರೀರೈಟ್ ಮಾಡ್ತೀನಿ. ಹೇಗೆ ಅಂದರೆ ಈ 1 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 3 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 4 ಸ್ಕ್ವೇರ್ ಐತಲ್ಲ ರೀ, ಈ ಟರ್ಮನ್ನು ನಾನು ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ. ಸೊ ಆನ್ ಅಪ್ ಟು 20 ಸ್ಕ್ವೇರ್. ಐ ಆಮ್ ಆ್ಯಡಿಂಗ್ ದಿಸ್ ಎಕ್ಸ್ಟ್ರಾ ಟರ್ಮ್. ಇವೆಲ್ಲ ಟರ್ಮ್ಗಳನ್ನ ಎಕ್ಸ್ಟ್ರಾ ಆ್ಯಡ್ ಮಾಡತ್ತೀನಿ. ಯಾವ್ಯಾವು? 1 ಸ್ಕ್ವೇರ್ 2 ಸ್ಕ್ವೇರ್ 3 ಸ್ಕ್ವೇರ್ 4 ಸ್ಕ್ವೇರ್. ಸೇಮ್ ಥಿಂಗ್ ಇವು ಸಬ್ಟ್ರಾಕ್ಟ್, ಅವ್ರನ್ನೇ ನೀವು ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡಿರಿ. ನಾವು ಇವು ಸಿ ಇಲ್ಲೆಲ್ಲ ಸಮ್ ಅದಾವ್ರಿ, ಮೀನ್ಸ್ ಇಲ್ಲೆಲ್ಲ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ ಅದಾವ್ರಿ, ಇವೆಲ್ಲ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ ಇದಾವೆ. ಅವೆಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಹೋಗ್ತಾವೆ. ಮತ್ತೇನು ಉಳಿತು ನಮಗೆ? ಅಗೇನ್ ವಿ ಲೆಫ್ಟ್ ವಿತ್ 5 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 6 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 7 ಸ್ಕ್ವೇರ್ ಅಪ್ ಟು 20 ಸ್ಕ್ವೇರ್ ಓನ್ಲಿ. ನೌ ಕ್ಯಾನ್ ವಿ ಯೂಸ್ ದಿ ಫಾರ್ಮುಲಾ ಸಮ್ ಆಫ್ ಸ್ಕ್ವೇರ್ಸ್ ಆಫ್ ಫಸ್ಟ್ n ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್. ಈಗ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಯೂಸಿಂಗ್ summation of k square where k varies from 1 to n means 1 square plus 2 square plus 3 square so on up to n square is equal to n into n plus 1 into 2n plus 1 whole divided by 6. We can use this formula now. ಇದು ನೋಡಿರಿ, 1 ಇಂದನೇ ಸ್ಟಾರ್ಟ್ ಆಗ್ಲಕ್ಕೈತಿ, ಎಲ್ಲಿಗೆ ಎಂಡ್ ಆಗ್ಲಕ್ಕೈತಿ ರೀ? ಎನ್ನಿಗೆ ಎಂಡ್ ಆಗ್ಲಕ್ಕೈತಿ. ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ಎನ್ ಐತಿ. ಇದು ಫಸ್ಟ್ನೇ ಸೀರೀಸ್ ನೋಡಿರಿ, 1 ಸ್ಕ್ವೇರ್ 2 ಸ್ಕ್ವೇರ್ 1 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ಲಕ್ಕೈತಿ, ಎಲ್ಲಿಗೆ ಎಂಡ್ ಆಗ್ಲಕ್ಕೈತಿ ರೀ? 20ಗೆ ಎಂಡ್ ಆಗ್ಲಕ್ಕೈತಿ. ಅಂದರೆ n ಈಕ್ವಲ್ ಟು ಏನು ಬರ್ತೈತಿ? 20 ಬರ್ತೈತಿ. ಎಸ್ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ದಿಸ್ ಈಸ್ 20 ಇಂಟು 20 ಪ್ಲಸ್ 1 ಇಂಟು 2 ಇಂಟು 20 ಪ್ಲಸ್ 1 ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ 6 ಮೈನಸ್ ಆಫ್ ಅದು ನೋಡ್ರಿ 1 ಸ್ಕ್ವೇರ್ 2 ಸ್ಕ್ವೇರ್ 1 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ಲಕ್ಕೈತಿ, ಎಲ್ಲಿಗೆ ಎಂಡ್ ಆಗ್ಲಕ್ಕೈತಿ ರೀ? 4ಗೆ ಎಂಡ್ ಆಗ್ಲಕ್ಕೈತಿ. ಸೊ n ಈಸ್ ಈಕ್ವಲ್ ಟು 4 ಇಂಟು 4 ಪ್ಲಸ್ 1 ಇಂಟು 2 into 4 plus 1. This is equal to, now we can simplify this. 20 into 21 into 2 into 20 40 plus 1 41 divided by 6 minus of 4 into 5 into 2 into 4 8 plus 1 9 by 6. Here 2 tens are 2 threes are 3 ones are 3 sevens are. Here 2 twos are 2 threes are 3 ones are 3 threes are. Simple. This become 7 into 1 7 fours are 28 into 10 is there, into 10 into 0 minus of 2 into 5 10 into 3 30. Okay, you subtract it. This is nothing but 2840. Sum of all these terms is 2840. Okay. Thank you.